gives me a great pleasure to introduce the first speaker in this session, Professor Francois Engelbrecht. Professor Francois Engelbrecht is a distinguished professor of climatology at the Global Change Institute of the University of Witwatersrand in South Africa. He specializes in climate model development and the simulation of Southern Hemisphere and African climate variability and change. Professor Engelbrecht served as a lead author of both the IPCC's report on 1.5 degrees and the Assessment Report 6 of the Working Group 1 report. He is an invited member of the Working Group on Numerical Experimentation of the World Climate Change Research Program. He's also the co-chair of the World Meteorological Organization Joint Expert Team on Earth System Implementation, and a scientific steering group member of the Climate Change and Ocean on Variability, Predictability, and Change Project, which is of the most 4 core projects of the World Climate Research Program. It now gives me pleasure to introduce you to Professor Engelbrecht. Professor Engelbrecht, over to you, sir. Thank you.
Thank you so much, Joe, for this very kind introduction, and many thanks also to Ian Rushworth for all the arrangements and the invitation for me to participate in the Conservation Symposium this year. And many thanks also to Freini de Toy for all the logistics towards getting me on board today. It is so fitting to present during this very first week of the 26th Conference of the Parties. And it's a great privilege for me to present in the symposium this year. I am sharing my screen. And let's go into presentation mode. So everybody, I will be talking about climate change and regional tipping points in the Southern African region from the perspective of what Mr. Drulani has mentioned, namely this recently published Assessment Report 6 from the Intergovernmental Panel on Climate Change. We have a fair bit of material to cover, so let's jump into the talk. In the last few weeks, in the build-up towards COP26, I'm sure you've also seen in the media how much attention the IPCC Assessment Report 6 has received. It has been rightly called Code Red, a Code Red for Humanity by the United Nations Secretary General. And today I want to explain why that is the case, also through a Southern African lens. But let me start by just mentioning that I think when we all switch on television nowadays, we can see unprecedented weather events occurring across the world, events that we are witnessing for the first time in our lifetimes. For example, in recent years, we've seen these unprecedented fires in California, in the Mediterranean, in southeastern Australia. That was also going on at a time when the report was released. We've had that completely historical heat wave in the Pacific Northwest at the end of June this year. And then, of course, the terrible flooding in Western Europe in July this year. And right now, we are facing a devastating drought in Madagascar, in the south. How many of these events can be attributed to climate change? Well, it turns out most of them can. And it turns out that the window that we have available to avoid these most catastrophic type of high climate impact events from occurring, that window is closed. So, let me get into the technical details of all of this. So I'm going to structure the talk. I'll just say a few more words about the assessment report here right at the beginning. Just take note of the fact that this has been composed by 234 scientists. It took about 3 years. We were from 65 countries, and these scientists reviewed the most recent evidence from climate change since the last assessment report, which dates back to 2013. In the end, more than 14,000 peer-reviewed papers were reviewed, and that formed the backbone of the eventual assessment published in the report. The big question now, and the acting CEO already alluded to that, is will this awareness lead to climate action at COP26? That is a question that will be answered over the next 2 weeks. And what will I be talking about today? I would like to explain again to everybody why certain thresholds of global warming are thought to be dangerous to the planet. So I'll explain why there is such a big effort to reduce global warming to below 1.5 degrees, preferably, otherwise below 2 degrees Celsius. And from that global basis, I'll talk about regional climate change, focusing on Southern Africa. And along the way, I'll also talk about global and regional tipping points in the climate system. And right at the end, I'll try to find some reasons for hope and action amongst all these risks we will be talking about during the talk. So here is the first science results from the global assessment. It's a graph that shows the level of global warming on the y-axis at the left as a function of time on the x-axis. And there on the right-hand side of the y-axis, you can see that the level of global warming, as we move deeper into the 21st century, depends to a very large extent on decisions we are going to make as humans. So we refer to those numbers on the right-hand side as so-called mitigation scenarios. Formally, they are called shared socio-economic pathways. Now, if we follow a future where we continue to grow the world's economy using fossil fuels, then you will see that we follow a future described by the dark red line. And towards the end of the century, we will be approaching global warming in the order of 5 degrees Celsius. On the other hand, if COP26 is successful against all expectations, and we see a wonderful collaboration from all the nations of the world, and we manage to restrict global warming to below 1.5 degrees Celsius by following this type of pathway into the future, then of course the most dangerous effects of climate change can still be avoided. Now, right now, as we meet today, the level of global warming is about 1.1 degrees Celsius, which means we've become very close to these dangerous thresholds of 1.5 and 2 degrees Celsius. Soon I'll explain again why these are thought to be dangerous levels of global warming. But for now, let me just mention first very startling finding of assessment report 6. The finding is that even if we follow the best possible mitigation pathway, so even if we have strong agreement amongst the nations for a best effort mitigation over the next 2 weeks, it is more likely than not that we will anyway, despite that, exceed 1.5 degrees Celsius of global warming, effectively because we've left the effort too late. Another important finding from the report, and that is good news, is if we have this best effort mitigation into the future, the chances are excellent that we will be able to restrict global warming to below 2 degrees Celsius. So what do I mean with best effort mitigation? Let's look at this graph. Here we have, once again, time on the x-axis, but now on the y-axis we have emissions of carbon dioxide. So once again, a future where we still use fossil fuels to grow the economy, where carbon dioxide emissions continue to increase into the atmosphere, is depicted by this dark red line. COP26 is trying to achieve agreement for this future trajectory. You can see that carbon dioxide emissions start to decrease immediately. Immediately means in the early 2020s. They are cut in about half compared to the present day levels by 2030, just in 10 years, a massive revolution in how the world generates its energy. Then carbon neutrality or net zero emissions is achieved more or less in the middle of the century. And after that, something very, very special happens. Emissions become negative. That means humans have invented new technologies that can, in combination with natural methods, remove carbon dioxide from the atmosphere. Now, this is called the best effort mitigation trajectory. Even if we get this right, we are still more likely than not to exceed 1.5 degrees Celsius of global warming. But as I've said, chances are excellent that we will be able to stay below 2 degrees Celsius. And if we can invent these types of technologies that can remove carbon dioxide from the atmosphere at an industrial scale, then we will be able to return the level of global warming to below 1.5 degrees Celsius in the second half of the century. So, now something about the economics of change. How on earth can we manage to reduce emissions, to cut emissions in half by 2030 and then continue and achieve carbon neutrality by 2050? Everybody knows it's an immense challenge. There are financial estimates available of what this will cost the world. And effectively, the International Energy Agency, which in itself is quite a conservative body, just a few months ago published its own set of guidelines of what we need to do in order to stand a chance to follow this strict mitigation pathway and restrict global warming to 1.5 degrees Celsius. The investment in the renewable energy sector needs to grow massively. It needs to reach a value of about $5 trillion US every year, annually. That is by 2030. It comes down to an investment of roughly $130 trillion US that is needed by 2050, accumulatively, to make the transition from the current fossil fuel infrastructure to renewable forms of energy. Some other specific sub-targets. The International Energy Agency recommends the end of combustion engine passenger cars by as early as 2035. So the transport sector needs to change. There should be an immediate stop to all new gas and oil projects. Coal wasn't even mentioned in this specific line because that is assumed to be the fossil fuel that should fall first in the 2030s. So no new projects, no new investments, no new drilling for oil or mining of coal. And then by 2050, overall, 70% of the electricity generation of the world needs to come from these renewable sources of energy. The International Energy Agency, in its projection, thinks that the renewable sector will not grow fast enough to fuel this change on its own. We will still need about 30% of nuclear energy in their estimate by 2050. Then along these lines, just maybe now a month ago, President Xi Jinping announced that China will no longer fund any new coal-fired projects abroad. And that policy change by China has just been confirmed at the G20 meeting yesterday. All G20 countries, if I understand the declaration of yesterday correctly, will now commit to no longer funding any new coal power plants abroad. So that means that South Africa's chances of funding another big coal plant, I think those chances are now 0. So that was all positive news towards COP26. But of course, in the last few weeks, if you follow the news, the conference lost some momentum. I won't go into all the details now, but the very, very big condition for success at COP26 is, of course, that the world's two superpowers, the US and China, will have to agree to cooperate on climate change mitigation, despite all the other disagreements they currently have. That's a necessary condition for success. If the two superpowers will not mitigate strongly and pursue carbon neutrality by 2050, with these rapid cuts by 2030, it's not realistic to think that we will be able to restrict global warming to even below 2 degrees Celsius. Now, right now, unfortunately, several countries are not yet ready to make that key commitment of net zero emissions by 2030. Cutting emissions in half by 2030. That includes China, who still envisages growth in its carbon dioxide emissions from coal until 2030. The same with India, the same with Australia, just to mention a few countries that do not seem ready to make the strong commitment for 2030. On the positive side, it seems as if during this COP, Japan, South Korea, the United Kingdom, the European Union, and the USA will all make that commitment of cutting emissions by half in by 2030. And even if these 5 economies, these 5 power economies on their own make this commitment, it will still result in the biggest shift in investment towards renewable energy the world has ever seen. So it's really a mixed bag. Not everything is negative at this point in time, in the first day of the COP. Let's see where we are 2 weeks from now. So, just 2 more slides on these global aspects. I'd just like to explain very briefly why 1.5 and 2 degrees Celsius of global warming are thought to be dangerous. This is the graph we already spoken about. Levels of global warming into the future as a function of the different mitigation scenarios. Same graph, same type of graph here, but here we are looking at precipitation into the future. And it's precipitation for the world's land masses. And maybe some of you will be surprised to see, because it's not something we expect in our region, but globally, on the average, precipitation is increasing. Across the world's land masses on the average. It's something that can already be detected, and it's something that will continue to strengthen into the future. Soon I will explain why Southern Africa is an exception in this regard. Arctic sea ice. In the late summer, around about mid-century, under these low mitigation futures where we don't make a strong effort towards converting to renewable energy, the precious ecosystem of the Arctic Ocean will be completely ice-free, sea ice-free. An absolutely remarkable change. That such drastic change can already be seen. The last decade was by far the decade with the lowest sea ice coverage above the North Pole. And then the original reason why 1.5 and 2 degrees Celsius were defined as dangerous. It's about sea level rise. Strong mitigation will give us a chance to restrict global warming to below global sea level rise to below 0.5 meter by the end of the century. But under these low mitigation futures, we will be approaching sea level rise of 1 meter towards the end of the century. That alone will be sufficient to displace hundreds of millions of people from where they currently live along the world's low-lying coastal plains. Global tipping points, what do we mean with that? It means, everybody, that we are now on the verge of changing the planet in an irreversible way. The report has assessed that somewhere between 1.5 and 2 degrees Celsius, we may reached a point where the melting of the Greenland ice sheet and possibly also the West Antarctic ice sheet will become irreversible. So we will initiate the irreversible collapse of these two major ice sheets. This will commit future generations to 12 meters of sea level rise. Our generation will literally make the world smaller for future generations to live in. Now, it will take millennia, of course, for the ice sheets to melt away completely. The estimate is that under sustained warming of 2 degrees Celsius, the sea level rise may reach a value of about 6 meters over the next 2,000 years. It feels very long, of course, in the lifetime of a human, but think a little bit about what that means for the world's population, for biodiversity, and how future generations will think about our generation, which was the last one that stood a chance to make this change and to avoid this catastrophic rise in sea level. And remember, sea level rise is happening already. It's already displacing people. There's already more coastal erosion. And during the century, under low mitigation futures, hundreds of millions of people will be displaced just by that 1 meter of sea level rise. So now I would like to talk in the remaining part of this presentation about regional climate change. And I want to bring the message home to Southern Africa. Please have a look at those 4 maps at the top. They are showing the level of global warming, 1.5 degrees Celsius at the top left map. And the patterns that you can see is how different parts of the world will have warmed up by the time that the world on the average has warmed by 1.5 degrees Celsius. You can see that the strongest warming in the world, there and at the top left, is occurring in the world's Arctic regions. Many reasons for that, but one of them is the positive feedback that occurs when the sea ice melts. So when sea ice melts away in a warmer world, more sunlight can warm the ocean. Previously, that sunlight, some of it would have been reflected back to space by the sea ice. Now the ocean warms even more sea ice melts, even less solar radiation gets reflected, and so forth. That's one important positive feedback process that works in the Arctic. But have a look in the Southern Hemisphere. If we look at the climate, the trends in temperature over the last 5 decades, the place in the Southern Hemisphere that is warming up the fastest is Botswana. That's also the projection into the future. So that's somewhat surprising. It's interesting from a climate perspective, but it's also a negative change that brings high impacts to our region. I'll talk about it a bit later on in more detail. As the level of global warming increases, you can see that Southern Africa warms up drastically. It's warming substantially faster than the global rate of warming. And 3 to 4 degrees Celsius of global warming will easily mean 6 degrees Celsius of regional warming in the Southern African interior. Now, the IPCC, in its big impacts report, 2018, it was called the Special Report on Global Warming of 1.5 degrees Celsius, found that under 3 degrees of global warming, it is likely that the maize crop in Southern Africa will collapse completely. And the cattle industry in Southern Africa will also collapse completely, purely because of the increased heat stress effects on that specific crop and on cattle. But these increases in temperature go along with decreases in precipitation. So here you can look at exactly the same type of map, but now we are looking at projected changes in precipitation. And the green regions are those parts of the world that are projected to become wetter, and brownish colors are those parts of the world that are projected to become drier. Think back of that graph I've shown you on global rainfall increases. You can see the northern hemisphere, high latitudes, are projected to become generally wetter. And that does come with risks. For example, more heavy precipitation. And we saw the textbook example, unfortunately, in July this year with the flooding in Western Europe. But still, when the high latitudes of the northern hemisphere, which are naturally wet and cool regions, become wetter and warmer, there are things that you can do in order to adapt to that type of change. Adaptation is far more difficult in our part of the world. We are already a water-stressed region. Our rainfall is generally low. About half of our region is semi-arid naturally. It's a warmer region. Now it's projected to become drastically warmer and substantially drier. I think it is clear to everybody, when a water-stressed region becomes much warmer and drier, the options for adaptation are limited. That is why our region has been identified as a climate change hotspot by the IPCC back in 2018. And that is why the potential for regional tipping points exists in our region. And now I would like to conclude by talking about those tipping points. I'll just show one more of these results from the report. I just want to point out that we have a very good understanding why the region is projected to become much warmer and drier. So climate science is very well developed for the region. The main reason, for example, why our winter rainfall region is projected to become generally drier is because of the poleward displacement of the westerly winds that bring the cold fronts to southern Africa. So in a warmer world, the cold fronts are progressively being shifted towards the South Pole, and it becomes increasingly difficult for these systems to bring rainfall to the winter rainfall region of South Africa and all along the Cape South Coast. Now, I want to talk briefly about 5 or 6 tipping points. I'll have to be quick in order not to exceed the time allocated to me. Number 1, our fossil fuel companies. This is an economic risk. They may be stranded assets in 2 weeks' time if COP26 is successful. It's clear that investment will shift away from fossil fuels, away from big oil, away from coal towards renewables. Our fossil fuel companies need to make the decision to be part of the solution and to use their wealth in some cases, or at least their substantial infrastructure, to make a conversion to become renewable energy companies. Massive challenge. Don't want to talk about it more today, but it's a clear risk for South Africa if we are not going to make this transition with the rest of the world. On the other hand, if we commit to the transition under the Paris Agreement, the world must commit to substantial investment into South Africa to make this transition. It's a huge topic. We can't go into it in detail today, unfortunately. I briefly want to mention 5 risks in terms of future climate change impacts in our region. A so-called Gauteng Day Zero drought, more frequent multi-year droughts impacting on our agriculture. The third one, more intense heat waves impacting on human health. 4th, a completely different type of risk, intense tropical cyclones reaching northeastern South Africa. And finally, I want to say something about tipping points in terms of biodiversity impacts. So I'll be very quick. At the end of the big drought of 2015-16, the level of the Waldheim has fallen to below 25%. If it falls to below 20% because of water quality regions and engineering reasons, pumping the water uphill to Gauteng, the Gauteng supply from the east, which is about 50% of the Gauteng supply, will immediately be severely compromised. We came close to such a day zero drought once before, at the end of that big El Niño drought. In a warmer and regional world, the risk for this type of drought is bigger than it has been over the next 20 years. This, I think, economically and socioeconomically, is the single biggest risk South Africa will face in the next 10 to 20 years because of climate change. Secondly, multi-year droughts also impact on agriculture. Just to give you an example, at the end of that 2015-16 drought, Botswana lost 40% of its cattle. The maize crop that summer, was 40% lower than for the previous year. IPCC assessed back in 2018 that 3 degrees Celsius of global warming, as I've already mentioned, effectively means the end of our maize crop, our staple food, and of the cattle industry. So it's absolutely essential for the Africa group and South Africa specifically to negotiate as strongly as it can for climate change mitigation to be as strong as possible. Otherwise, our regional world as we know it will change into something completely different somewhere in the second half of the century. But of course, the impacts are already with us and will impact on our economic growth over the next 10 and 20 years in a very negative way. Heat waves. The recent heat wave in the Pacific Northwest killed hundreds of people. In British Columbia and in the northwestern states of the USA, simply because the people there are not used to heat waves. They don't have air conditioning, and hundreds of people died when the heat wave struck. It should be a warning sign for us. Most of our people don't have air conditioning. If you live in informal housing without air conditioning, especially if you're an elderly person and you don't have easy access to cool water, a heat wave is life-threatening. The IPCC report, published just now in August this year, is clear that the heat waves of the next 10 to 20 years will be completely unprecedented in Southern Africa in terms of intensity. It's a clear risk. We are not prepared. In northeastern South Africa, heading towards the end of the talk, we had some cyclones in inverted brackets reaching this region in the past. The best example is Cyclone De Moina 1984, but in today's classification, Cyclone De Moina, which caused a lot of lost a lot of damage and loss of life, is not even classified as a Category 1 hurricane. In a warmer world, it's possible for the first time that a devastating type of weather system, a Category 4, Category 5 hurricane, can move as far south as Maputo or even Richards Bay in South Africa. Such an event occurred on the 14th of March 2019 at Beira. When Tropical Cyclone Idai made landfall, it killed more than 1,300 people, the worst flood disaster humans have ever recorded in Africa, south of the equator. So that's another type of event, unprecedented, that can now occur further to the south in Southern Africa. Finally, other speakers in this symposium will talk more about impacts on biodiversity. I'll just mention 3 impacts and then I'm done with this talk. Think about the fynbos. It has evolved in a cool, wet winter climate. Now those winters are becoming drastically warmer, drier. There can be more fires in the fynbos. What does that mean for biodiversity? Bush encroachment. Many of you are certainly working on that problem. Obviously, in a warmer world, fewer frost events, more carbon dioxide. Trees are favored over grasses in the pristine eastern grasslands. And then just remember what happened in Kruger Park with the big drought, with the heat waves, the depleted grazing, at the end of the big El Nino drought in 2016. Climate science is clear. These types of droughts and heat waves will occur more frequently over the next 20 years. So to conclude, everybody, a lot of risks we have to face. I'll just say 2 more sentences. 1, climate science gives us a grip on these risks. We know to a large extent what the risks are. So we can prepare at least to some extent to what's coming. There are limits to adaptation, but there are also some adaptation measures we can take. That is critical for South Africa. It's critical to get that adaptation funded, also through the processes happening around COP26. And secondly, the level of global warming is still in our hands. We may not be able to avoid the 1.5 degrees Celsius of level of global warming anymore, but if COP26 is successful, there's an excellent chance that we can still restrict global warming to at least below 2 degrees Celsius and avoid the most dangerous impacts. So despite all these terrible risks we do have to prepare for, there's still hope. And with that, I return the floor to Joe. Thank you very much, Joe, for the opportunity.
Thank you very much, Professor Engelbrecht, for the very informative and really curious talk about what is happening in the space of global change internationally and in the Southern Hemisphere. I have got a couple of questions. Well, I have questions of my own, but I can leave that till later on. I'll take about 3 questions that have come from the floor, 2 from El Sabe van Skalbeek, and then 1 from Bruce Page. From El Sabe, the first question is, please share your perspective on the drive of green hydrogen. That's the first question. Second question is, what impact will desalination plants have on climate change, if at all? And then the last question is from Bruce Page, and it reads thus: how do you counter arguments that elevated CO2 increase productivity of especially food crops, but also benefits natural systems? Surely the effect of elevated CO2 on growth offsets the effects of higher temperatures and less rain. I have those for now. Please, over to you, Mr. Professor Engelbrecht.
Thank you very much, Joe. Well, green hydrogen is certainly part of the potential future energy mix. So we should realize that there are some environmental risks associated with, for example, a growing green hydrogen sector in the economy, as there are risks with, for example, building more solar and wind farms. We, for example, need to mine for the rare metals that are used in solar farms. So there are environmental risks associated with green energy as well, but those risks are an order of magnitude smaller than the tremendous damage that coal mining and coal pollution and global warming brings to the environment. So I think, for example, for South Africa, it is in fact essential for our economy that Sasol, for example, is able to transition its way out of being a fossil fuel company. They should be seen as part of the solution of the just transition in South Africa. And their pursuit of green hydrogen is a pursuit that I personally hope will be a success. And I hope they will get funding and increased investment to make this big transition they've now committed to. So they've now committed to carbon neutrality by 2050. And they want to have emissions reduced with 30% by 2050. Strongest commitment they've ever made. But for that, they do require, as I understand it, investment in terms of their green hydrogen vision of growth. So I hope that answers the question. Of course, we have to be extremely careful. I think what we are seeing in the Congo now in terms of the mining of rare metals and minerals at the expense of people and children shows us also that the type of mining that is eventually needed for the renewable sector can also be done in a harmful way. So we have to learn and hopefully not make the mistakes of the past when it comes to the environmental damage from specifically mining. Desalination, I think the city of Cape Town can only grow in a sustainable way if it finds a new water resource. I think the 2015 to 17 day zero drought showed us that the Theewaterskloof Dam and big dams is not going to be able to sustain Cape Town's growth. They need another water resource. Now, I know there's a lot of effort on exploiting the water table to a larger extent. I'm not an expert in that field, and I don't know how sustainable that is or what the environmental risks are. Desalination is a solution, but it's very expensive and it requires a lot of energy. So if we build big desalination plants along the Cape South Coast or along the West Coast, it is a potential solution for the water scarcity of the future, but how will those plants be fueled? So energy will be needed. It certainly can't be coal-fired energy. I really hope it won't be nuclear energy. So innovative ways are necessary to use renewable energy to fund maybe a set of smaller desalination plants all along the coast. Not my field of expertise, but that's what I'm hearing that the energy experts are talking about. So desalination is potentially an important part of our future water resources, desalinated water. And then finally, no, increased carbon dioxide, the damages are by far overwhelming. It doesn't matter that some plants can get advantages out of increased levels of carbon dioxide if they all perish in multi-year drought. So remember, the multi-year droughts are projected to be absolutely devastating, bringing the end of the maize crop. So the combined effects of reduced precipitation and more heatwave events by far overwhelms the benefits that some crops can draw from increased carbon dioxide. I think one important exception is the potato crop. As long as you have irrigation for potatoes, it does draw great benefits from the enhanced carbon dioxide, and it can withstand the temperature increases. So the potato crop may increase, but only if you have irrigation available, and that is not a certainty in a drier world.
Thank you very much, Professor Engelbrecht.